Hi everyone. Today also we are going to learn about electricity. This is electricity part 2. Before starting the lesson today, let me remind you what we have learned in the previous lesson of electricity. First, we learned some measurements of electricity, mainly potential difference and the current flow. And then we learned how to measure the potential difference and the current flow in a circuit. Now, you know what are the instruments used to measure the current flow and the potential difference. Current flow is measured by the ammeter. Potential difference is measured by the voltmeter. When the ammeter is connected to a circuit, the ammeter is connected in series. Now, you know what the series method is, right? When the voltmeter is connected to a circuit, it is connected in parallel. Then we learned the relationship between the current flow through a conductor and the potential difference across it. Under that, we learned a law called Ohm's law. Let me remind you what the Ohm's law is, children, right? When the temperature of a conductor remains constant, the current flows through the conductor is directly proportional to the potential difference across it. After learning the Ohm's law, we derived an equation. What's that equation? V equals IR. Finally, we did some calculations to find the potential difference when we know the resistance and the current flow through the circuit using this V equals IR equation. Now, today we are going to learn the next measurement of electricity, that is resistance. We will see what this resistance is, children. Right. The obstacle for the flow of current through a conductor is called resistance. When there is a resistance in a circuit, in a conductor, the flow of current decreases. Resistance can be measured by the ohm meter. Oh children, here ohm meter is the particular instrument. If there is no ohm meter, we can use a multimeter too. You know that the multimeter can be used to measure the potential difference, current flow and the resistance all together. Then the unit of measuring resistance is ohm. Circuit symbols to denote, represent the resistance in a circuit are these symbols. Right. Now, look at these two circuits, children. Right. Here in a one circuit, you can see a high current flows and the brightness of the bulb is so high. For both circuits, same batteries are used, and in the second circuit, what you can observe, children, here the current flow has decreased and due to that the brightness of the bulb is low. What's the reason? What's the reason for that, children? Here you can see there is a resistor connected into this second circuit. That means when there is a resistance in a circuit, current flow decreases. Due to decrease in the current flow, brightness of the bulb decreases. Right. Let me show you this, children, by doing a simple activity. Right. Please look at here. Here I have taken two dry cells and a LED bulb, right, and a resistor. I think you can't see this resistor as this is too small. So, I will show you. Because of that, these are different resistors. We are going to learn about these resistors later in this lesson, children. Just have a look at up here for now. Just have a look at only. I will explain what are resistors later. When a resistor, such a resistor is connected to a circuit, children, a resistance, a barrier is provided to a circuit. Because of that, current flow decreases, and if there's a bulb like LED, the brightness of the bulb also decreases because of that. Okay, we'll first connect the circuit without a resistor, children. Now, you can look at here what will happen. When I connect, here see the brightness of the bulb, children. Please observe this carefully and just see the brightness of the bulb. Now, I am going to connect the same circuit with same cells to a resistor. Here I have a small resistor. Now, I am going to connect this to a resistor. See. Now, see what will happen to the brightness. When the resistor is connected, now look at the brightness. See, children, the brightness of the bulb has decreased a lot. That's because of the resistor. When there is a resistor connected to a circuit, the resistance is provided to a circuit, then the current flow decreases. Right. We'll learn more about resistance, children, right? Now, we are going to learn the factors affecting the resistance of a conductor. Children, when we use different conductors in different circuits, mostly we use copper, aluminium, iron wires, nichrome wires in our circuit. Depending on the requirement of the circuit, different wires are used. When we use these conductors, their conductivity is different, children, because these wires too have a certain internal resistance in them. When the current flows through these conductors, most of the times these conductors are getting heated. Because of heating, a resistance is given to the circuit and the current flow decreases. Now, we are going to learn what are the factors affecting the resistance of a conductor like copper or nichrome or aluminium, right? See, the factors affecting the resistance of a conductor. First, length of the conductor, then area of the cross section of the conductor, then resistivity of the material of the conductor. Resistivity, children, resistivity is a particular factor depend on the material composition of the conductor. If the conductor is made of nichrome, then it's a different material and it has a greater resistivity. Because of that, a nichrome material, a nichrome wire can exert or provide a high resistance to the circuit when it is connected. When we take copper, conductor copper, it has a low resistivity. Because of that, when a copper wires are connected in circuits, they provide low resistance. Okay, Children, now we'll learn how each factor is affected on the resistance of a conductor. Look at these simple circuits on the screen, children. Right. First, see these two circuits. Here, in a one circuit, a long nichrome wire is connected and the other circuit, short nichrome wire is connected. What can you observe in the ammeters, children? What can we say about the ammeter readings? See, when the long nichrome wire is connected, ammeter shows a very low reading. Why? Because there's very low current flows through this circuit. Why the current flow is less, children? Because of the high length of the nichrome wire. That means when the length of the nichrome wire increases, the resistance too increases. Because of the high resistance, current flow decreases. Here, as the length is low, as the nichrome wire is short, children, the resistance is not much more, and as there is less resistance, a greater current flows through the circuit. Thereby we can understand, what we can understand, children? We can understand when the length increases, length of a conductor increases, resistance too increases. Right. Now look at this. What you can see? Here there are two conductors of same length, but there's a difference. One conductor is having a high diameter, that means high cross-sectional area, and the other one is low. Then which ammeter shows a greater reading, children? The ammeter connected to the high cross-sectional area of the wire with the high cross-sectional area shows a high reading. Why? Because it has a less resistance, children. That means when the cross-sectional area of the conductor increases, resistance decreases. As the resistance decreases, current flow increases. Right. Now look at these two circuits. Here, two wires or the two materials are used, same length, same diameter, same cross-sectional area. One is copper and the other one is nichrome. Then which ammeter shows us the greater reading, children? The ammeter connected to the copper wire gives a greater reading. That means a high current flows when the copper wire is connected. That indicates that when the copper wire is connected to the circuit, resistance is low. Because of that, current flow increases. Why? Because the material composition of copper. Due to the different material composition in copper, it has a very low resistivity. When the resistivity of the material is low, the resistance also low. Here nichrome has a greater resistivity. Because of that, nichrome provides a high resistance. Then the ammeter reading decreases because of the high resistance of the circuit. Okay, right. Finally, what we can understand by all these experiments, all these activities, children, see, the resistance of a conductor increases with the length of the conductor. When the length of the conductor increases, resistance too increases. Next, the resistance of the conductor increases when the cross-sectional area of the conductor decreases. Can you remember when the wire with the high cross-sectional area is taken? Resistance low. So, resistance low when the cross-sectional area is high. Resistance high when the cross-sectional area is low. Third one, the resistivity of the material too affects on the resistance, children. When the resistivity is high, resistance of the conductor too high. Now, we are going to see actually this happens, children. Okay, let me explain by doing a simple activity whether the material composition affects on the resistance and what happens when the length is high and what happens when the cross-sectional area of the conductor is high. Okay, I have an ammeter here. I have an ammeter, children, and different wires of different length, different diameter and material with different materials are taken here, children. Now, here this is a nichrome wire, right? This is a nichrome wire, children. This is a copper wire of the same length, copper wire, right? Now, I am going to show you what happens to the current flow of the circuit when the circuit is connected to the nichrome wire and to the copper wire. Right. First, I am going to join to the nichrome wire, children. Now, see the ammeter reading. See the ammeter reading, what happens, and the ammeter reading. Again, I am going to switch off. Right, now again I am connecting. See the ammeter reading. It's about 0.4 amperes. Right. Now I am going to connect to the copper wire. See what will happen. See what will happen. Right. When the copper wire is connected, right, there is a wire shortage, children. Wait, I will explain again. Right. When the copper wire is connected, right, see the ammeter reading. Right, okay. Now, I am going to show you what happens when we connect the circuit to a copper wire with a high diameter, high cross-sectional area. See, the ammeter reading is 1.5. Now, I am connecting to a wire with high cross-sectional area. Now, I am connecting to the same copper wire with a less cross-sectional area. See the reading. See the difference, children. Right. Okay. Now, I think you got a very good understanding about how the factors length and the cross-sectional area and the material composition of a conductor affects on the resistance. Right. Now, we are moving to the next part of the lesson, children. Right. Now, we are going to learn what are resistors. What are resistors? Okay. See here, you can see different types of resistors on the screen, children. These are called resistors, right? These are called resistors. We'll learn later what kind of resistors are these, right? Resistors. The resistor is the part of an electrical circuit that resists or reduces or lessens the amount of electricity passing through the circuit. When a resistor is connected to a circuit, children, it provides a barrier or obstacle to the flow of current. Then the current flow of the circuit decreases. When such a resistance can be given externally to a circuit, that device is called a resistor. A resistor. There are different types of resistors, children. Mainly two basic types of resistors called permanent or fixed value resistors and variable resistors. Okay, please go through, children, this. Right? Why do we use resistors as they provide obstacles to the circuit, children? Why do we use them in our circuit? Why are we using all these resistors? Because they are barriers. Because of the resistors, current flow decreases. Then what's the purpose of using resistors in circuits? There are certain reasons, children. What are they? Sometimes in different circuits, we have to connect electronic devices like diodes, transistors and some other electronic parts. They use a small current to operate. In these cases, we have to control the current flow through the circuit because we need to send the right amount of electric current through each part of the circuit. In this case, we have to get the use of resistors because in order to control the current flow as required, as we wish, we need resistors. Okay, right. As I told you earlier, there are few types of resistors, children. What are the few types of resistors? Fixed value resistors, variable resistors, light dependent resistors. In short, light dependent resistors are called LDR. LDR also a kind of variable resistor. I'll show you what a LDR is later. Right. First we'll see what are fixed value resistors. Fixed resistor is a resistor which has a specific value and we can't change the value of fixed resistors in circuits, children. When fixed value resistor is connected, permanently that resistor provides a certain resistance. We cannot change the value. The values are mentioned on fixed resistors like 10 ohm, 100 ohm, 1 kilo ohm. Likewise, particular values are mentioned. According to the value and according to the requirement, we can use them in our circuit. Right? See the circuit symbols of fixed resistors. If a fixed resistor is connected to our circuit, it must be represented by this particular symbol, children. Okay. Here, these are the types of fixed resistors: carbon composition resistors, wire wound resistors, thin film resistors, thick film resistors. Likewise, there are different fixed value resistors, children. Here I have some fixed value resistors in my hand. You can see these different fixed value resistors. On these resistors, children, you can see some color bands available. I'll explain later what's the meaning of printing color bands, different color bands on these resistors. Okay, right. What's this, children? This is a resistor color code. Color code resistors. As I told you earlier, now I am going to explain what a color code resistor is. Resistor color coding uses colored bands to easily identify a resistor's resistive value, children. These color bands give us a way to identify the value of the resistor here. Value of the resistor means, children, what's the value means if it is 100 ohm or 500 ohm or 1000 ohm. The value of the resistor can be decided by using these color bands. Now, I am going to explain you how the resistance value of a color code resistor is found and identified. Here, look at this particular resistor with color codes, children. You can see here there are 4 color bands. There are such resistors with 5 color bands too, children, but here in this level, according to your syllabus, we use only 4 color band resistors. Here you can see there are 3 bands together with different colors, and one band is a little separated, and the 3 color bands are named as first band, second band and the multiplier. Third band is also called multiplier, and the fourth one, which is separated, is called the tolerance. I'll explain the meaning of all these things, children. Don't worry. Here, what's this? This is the resistor color code table. This is called the resistor color code table, children. In this table, for each color, a code number is given. A code number, right? You can see here for the black color 0, brown color 1, red color 2. But children, you don't need to study these code numbers by heart, and you don't need to remember all these numbers, right? When this type of a question is given to you in your paper, the color code numbers are given to you. Then you don't worry, you don't need to remember these color codes. Why we need these color codes, children? To find the value of the resistor, particular resistor with color codes. Now we are going to learn how to identify the value of a particular color code resistor. See, first we have to use the first color band and get the code number relevant to the first color band and write it. Okay. Then we have to get the second color band and get the code number relevant to the second band and have to write after that. Third, then we have to find the color of the third band and get the number relevant to the third color band and not write the number, but we have to put equal number of zeros to the third color band at the end. Wait, children, I will explain how to do this. Right, look at here. This is a color code resistor. Okay. Now, I am going to show you how to find the value of the resistance of this particular color code resistor. See, here the first band is, first color band, color is brown, right? What's the code number relevant to brown? 1. Right. First we have to write 1. This is the code number relevant to the first color band. Then what's the second color? Second band is black. What's the code number relevant to black? 0. Then after 1, you have to write 0. Right. Then take the third band. What's the color? Red. The code number relevant to red color is 2. We are not writing 2 here, children. Instead of writing 2, we must put equal number of zeros. Number is 2, because of that we can put 2 zeros at the end. Now we get 1000, value is got as 1000 here. That means the value of this particular resistor is 1000 ohm. Then what's the purpose of the final fourth band, which is separately printed? This fourth band gives us the tolerance percentage of this particular resistor, children. Tolerance percentage. How to get the tolerance percentage? If the fourth color band is a gold color band, tolerance percentage is 5%. If the fourth color band is silver, tolerance percentage is 10%. Here the fourth color band is gold, children. That indicates the tolerance percentage here is 5%. That means this particular 1000 ohm resistor is tolerated plus or minus 5%. Plus or minus 5%. That means 5% of the 1000 ohm value can be reduced or 5% can be increased. That's the meaning of giving this tolerance percentage, children. Okay. Then we'll do another calculation, right? Look at here. Now I am going to show you how to find the value of another resistance, children. Then this will make you understand properly. Okay, look at here. Answer the questions based on the color code resistor given. Right? Find the resistance value of this particular color code resistor. Okay. Now look at here, children. First band is red. What's the number relevant, code number relevant to red? 2. Then you have to write 2 here. First number must be written. Then the second band is green. What's the code number relevant to green color? 5. Here after 2 we have to write 5. Then get the third band. Third band also here red. What's the code number? 2. Don't worry, children. Code numbers are given to you. You don't need to worry, right? Third band is red again and the relevant number is 2. Now do we put 2 here, children? No. Instead of putting 2, we must put 2 zeros at the end. See. That means the value of the particular resistor is 2500 ohms. Okay, right. Then move to the next. Here, find the true, what is the tolerance value of this particular resistor? Here, the fourth band is gold again. When there is gold color band, tolerance percentage is 5%. Then the tolerance value is 5%. Then how to write the particular resistor value with the tolerance value? Now we got the resistor, value of the resistor as 2500 ohm plus or minus 5%. Plus or minus 5%. Then finally, find the true range of values that this resistor could have. Then how to find the true range of values that this particular resistor could have? You have to get 5% out of 2500, children. What is 5% out of 2500? Here you have to get 5%. What is 5% here? 125. 125. That means 2500 plus or minus 125 ohm. Right. When you subtract 125 from 2500, you get 2375. When you add 125 to 2500, you get 2625. Then this is the true range of values that this particular resistor could have, children. Okay, this is how to find the resistance value of a color code resistor. With that, we completed learning about fixed value resistors. Now we are going to learn about some variable resistors. Okay, right, children. What are variable resistors? A variable resistor is the type of resistor which changes the flow of current in a controlled manner by offering a wide range of resistances. Just remind the activity we did in the previous lesson, children, under the Ohm's law. To prove the Ohm's law, we used rheostat. Can you remember? Using the rheostat, what we did, children? The rheostat was adjusted to change the current flow in the particular circuit. Can you remember? Right? That means the rheostat is a variable resistor that can change the resistance in a circuit. Okay. There are few types of variable resistors, children. Right, before that, just learn how to represent the variable resistors in circuit diagrams. See, circuit symbols are this. An arrow is put across the symbol of resistor that indicates change in, that indicates that the value can be changed. Okay. Here these are few types of variable resistors. I have real volume controller and another variable resistor. You know, this is familiar to you, children. This is the rheostat we used in the previous lesson. You are familiar with this. By changing here, this is the slide-in contact. By moving this slide-in contact, value of the resistance can be changed. Okay? Right. This is another variable resistor. This is called a volume controller, children. This is called a volume controller, right? Here, you know, you may have seen this in your cassette players. When you rotate this to control the volume, actually by rotating what we do, children, we change the resistance here. We change the resistance, you know. When the resistance is increases, current flow decreases and the volume of the cassette player decreases. When the resistance decreases, current flow increases and the volume increases. So, this volume controller is also a type of variable resistor. You can see a picture of a volume controller here on the screen. Right, okay children. Now, we are going to talk about LDR or light dependent resistors. Okay, right. What are light dependent resistors, children? See, light dependent resistor or LDR, which is also called a photoresistor because it changes its resistance depending on the amount of light falls on it, right? It consists of a piece of semiconductor material that acts as a variable resistor. The resistance of LDR changes on how much of light is shining on it. See the picture of a LDR given here on the screen, children. This is the circuit symbol to represent LDR when it is connected in a circuit. Now, look at this, children. What happens when a LDR is connected to a circuit? When the bright light falls on it, its resistance decreases. When there is no light, when it is dark, its resistance increases. Right? When a LDR is operating in a circuit, the current flow is controlled depending on the amount of light falls on it. This is how LDR is operated in a circuit, children. Please look at the circuit given here with an LDR. There is no light to LDR, that indicates it is dark, no light. Right? What happens when there is no light, children? The resistance of the LDR increases to a greater value. Because of the high resistance, no current flows through the circuit. Sometimes current flow decreases to a very less value, or sometimes completely the current flow stops. When there is no current flow, the bulb is not lighted, right? Now look at the other one. See, now a bright light falls on the LDR. When the light falls on the LDR, its resistance decreases. Then the current flow starts through the circuit and the bulb is lighted. Let me show you this, children. Let me show you this. When the bright light falls on the LDR, children, the resistance of it decreases and the current flow increases. Because of the flow of high current, the bulb is lighted. Let me show you how this happens really. Okay? Right. Now look at here, children. I have a simple circuit with a LED bulb and two cells. What's this? This is a LDR, light dependent resistor. Right? You know, children, when there's no light, when it is dark, resistance decreases, resistance increases and current flow decreases. Now, I am going to show you this, children. Right. Here, see, when I connect the circuit, LED is lighted, right? That means light falls on the LDR. When the light falls on the LDR, its resistance decreases and current flow increases and the LED is lighted. Now, I am going to close this LDR. See what happens. See the brightness of the bulb. Again, right? Now, light falls. Now, I am going to close. no light for the LDR. That means resistance increases. A greater resistance is provided to the circuit. Because of that, current flow decreases and then there's no enough current to light up the LED. LED is off. Okay, children. With that, we have completed the content that we have to learn in this lesson. Now, we are going to do some exercises. Just I want to know whether you understood my lesson properly, right? See whether you can answer these questions. Okay, children. Here, given below is a circuit arranged by a group of students to test some factors affecting for the resistance of a conductor. Answer the questions given below based on it. Right. A and C are nichrome wires with same diameter and different lengths. B is a copper wire with same dimensions as A. C. A and C are, children, A and C are nichrome wires. One is long and the other one is short. Different lengths. B is a copper wire having a same length to the A nichrome wire, same diameter, right? We have cells connected and an ammeter and a bulb, right? Let us see the questions based on this. Okay. What happens when the pointed end is contacted with A, children? Right, now look at here. If we take this pointed end, as I explained you in the activity, children, now this question is based on the activity we discussed, right? If this pointed A is taken and contacted with A, the current flows through the circuit and ammeter shows a certain reading and the bulb also lighted with a certain brightness. Then as the answers, you have to tell ammeter shows us reading and ammeter indicator of the ammeter deflects and bulb is lighted. As the observation, you can write these things, children. Okay. Then look at the next question. Give the change in your observations when the pointed end is contacted with B, right? Remember, children, you must mention the observations, right? Now, when the pointed end is contacted with B, what will be the changes in our observation? Right, you know, A is a nichrome wire, B is a copper wire. You know that when the pointed end is contacted with B, definitely the resistance should decrease. So, definitely the ammeter shows a greater reading, ammeter deflects more and the brightness of the bulb must increase. Then as the answer here, give the change in your observations when the pointed end is contacted with B. You have to write ammeter reading increases and the brightness of the bulb increases. Okay, right. Now look at the next question. What is the reason for your observations in the question number 2 above? What's the reason? Because of the change in the resistance. We know when it is in contact with A, resistance is high. When it is in contact with B, resistance is low. So, what's the reason? because of the difference of the resistance provided by the two conductors. Which factor affecting the resistance of a conductor is tested by A and B? When we compare the observations with A and B, which factor affecting the resistance is tested, children? Material composition or the resistivity of the conductors. Resistivity or the material composition of conductors. Next question. Give the expected observation in the ammeter when the pointer is touched A and C in order. See, children, when the point is touch A, it's long nichrome wire. When it is touched to C, it's a short nichrome wire. You should know that, children. We learned that when the length increases, resistance increases. Here you have to give the expected observation in the ammeter with contact in A and C. Then you have to tell when the pointer is contact with A, ammeter reading low, less reading. When it is contacted with C, ammeter shows a greater reading. This is only, that's only, right. Number 6. Which factor affecting the resistance of a conductor is tested by A and C? Length of the conductor. We know that when the length increases, resistance increases. Okay, right. Now move to the next one. Last question. Observe the circuit given below and answer the questions. Name A in the circuit. What's A here, children? What's A? Here A is a light dependent resistor or LDR. A is a light dependent resistor. Now, I think you can recognize the circuit symbol, right, children? Second question. What can you observe when light falls on A? When bright light falls on A, children, you know that resistance decreases and a current flow starts through the circuit. Due to the flow of current, this is an electric bell, children. Then this bell must be worked, right? Then what should be the observation? The bell produces a sound or the bell rings. The bell rings. Third question. What is the reason for your observation? As the reason you have to tell, when light falls on the LDR, its resistance decreases. Due to the decrease in of resistance, current flow increases, and as the current flows through the bell works. Okay, children. With that, we have come to the end of the lesson. Children, I hope that you got a very good understanding of the lesson today. And I will meet you again with the third part of this lesson too, children. See you again with the next part of this lesson, children. Goodbye, children.